Okay, today's lecture, we're going to break parts of a circle down, okay? This is section 2. We're going to deal with arcs and angles. Okay, the resources are pages 7 to 9 in the notes I provided, and section 2 on the PowerPoint, okay? Terms we're going to deal with here. First off is a central angle, okay? As the name implies, it is central to the circle. So the vertex of the angle lies on the center of the circle, okay? So if we were to name this angle right here, it would be angle AQE, for example, okay? The vertex is the center. Next, an arc differentiates between the arc with eminence on it because this arc is with a C for circle. Ooh, see what I did there? Okay, whereas an arc with kangaroos would be with a K. Just saying. Okay? So, an arc is the distance on the circle between 2 points. So the distance from D to E. The distance from A to B. That little is an arc. Okay? And that's the symbol we use for it. Okay? So, when we are looking at a minor arc, it is one that is less than a half circle, so less than 180 degrees. And we use 2 letters to name that. Okay? So, EA. Okay? And it's a little arc like that goes over top of the letters. So that's when it's 2 is a minor arc or a semicircle, which is exactly a half circle. Look for the endpoints of a diameter. That's your key. Okay, so in this one, AD is a diameter. So AD or DA would be that particular arc. Okay? Now a major arc. Major arc is bigger than a half circle. Okay? Bigger than a half circle, but less than a full circle. So, we're going to use 3 letters to name it. Okay? And here's why. If I look at the arc and I say, okay, I want to find the measure of DE, do you, the person I'm talking to, know whether I mean this or this? That's why we use 3. If we talk about the minor arc, we're talking about DE right there. If I want the major arc, I go D, choose any of these points, and end with E. So if I was to say D, C, E, you would know which way to go around the circle. Okay, and it'll look like that. Now, if I want a real arc length, okay, think about it for a second. If every circle, regardless of its size, is 360 degrees, and I say, oh, that's an 80-degree central angle, that's going to be an 80-degree arc. So will a circle as big as this room have an 80-degree arc. It's very imprecise, okay? And here's why that works. If I have a circle that's 360 degrees, yeah, you can barely see it. And there's one, and there's one. Those are all 360 degrees, right? And because the angles come through, each of the arcs formed are going to be the same. Okay? So that's why a central angle is equal to the arc it forms. Okay? Central angles are equal to the arc they form. And they're going to be degree measures, but we can do better. Okay? If you remember the circumference of a circle, 2 times pi times the radius. Well, what we're going to do here is this. N over 360. 360, the entire circle. The n is the measure of the arc you want to find. So if I know that that's 30 degrees, I say 30 degrees over 360 times 2 times pi times the radius of the circle. That's going to give you the distance, okay? And if you want to leave it in pi, that's one way to do it. If you want to multiply by 3.14, that's another way to do it. Okay, we're going to look at those. Okay, let's head over here. Okay, we'll start with our examples. Okay, let's start with this one. There we go. Okay. The directions here, which you can't see, AC and DB are diameters. Important to know because it cuts the circle in half. Identify each of these as a minor arc, a major arc, or a semicircle, and find the measure. Okay, I'm going to tell you right now, in my opinion, it's best to go through and put the measures in already. Okay, I have a half circle there. Okay, so that means I've got 100 here. 180 minus 100 is 80 degrees. Okay, here's the key. This angle and this angle are vertical angles. We know they are equal. Okay, we also know that this is another diameter. So that's 180. Well, if I've got 130, 180 minus 130 gives me 50 degrees. I have every possible measure I could work with here. So let's look through. AE, 50 degrees. Okay, EDC. This book tends to use 3 from time to time on minors. Make sure you're following where it's going. E through D to C. 50 plus 80 is 130. Okay, ABC. Endpoints of a diameter. That's a half circle. Okay, AB. Okay, ADC. They tried to trick you right there. It's still a half circle. Okay, BC. From there to there, 100. Okay? So, minor arc, major arc, or half circle. Minor, minor, semicircle, okay, minor, semicircle, minor. No major arcs in this particular problem. Okay? So that's the first one. Pretty straightforward, pretty easy problems. Okay, we come up here now. Okay? Now, in this particular one, did I forget to put a couple of numbers in? Yes, I did. Okay, because that's 38 right there. Okay. So, on this particular problem, it says FH and EG are diameters. Find each measure. Same thing. I'm not going to go to these till I'm filling everything I can right there. Okay, so let's do so. I've got a half circle, okay, and of that I have 38 and 90, okay? 90 plus 38 is 128, subtracted from 180, 52 degrees. Okay? Vertical angles are equal. If that's 38 That's 38. Okay, I have a half circle. That's 180 degrees. 180 minus 38, 142. I have all the angles and therefore the arcs already. Here we go. EF, FG, DFG, there's a major, 52 plus 38 plus 142, okay. Just add them up, okay. DE, DHG, 90 plus 38, and DGE. Look at this. We have two possibilities here. We can add 90 plus 38 plus 142 plus 38, and that will give me the correct answer. The other way, I'm only missing that from the circle. I can say 360 minus 52. Both will give me the correct answer. Okay? Okay. I'll take this. Oh, let's grab these just because. Okay. And head over to our sideboard. Okay, here we go. Okay. Now this is the one where I told you about we're going to find the length beyond just degree measures. Okay? This is far more efficient and precise. Okay? So, find the arc length using the given information. Once again, I have some degree measures in central angles. I'm going to use that to find all of them and the arcs, which I need, because remember your formula, n over 360 times 2 pi r. Okay, so first things first. Okay, diameter. So that's 60 plus 90 is 150. That means this is a 30-degree angle. Once again, diameter, I have 20 here, 160 over there. Okay, so those are the x's I'm going to use in this problem. Okay, here's my next one. Find Q, P, T. If QZ, okay, what's QZ? QZ is a radius. Okay, so here we go. The degree measure, I'll use this. Okay, first things first, what's my n? Well, from Q to P to T, 90 plus 30 is 120. Right? Okay, pi, we're just going to use for this is 3.14. Okay, we'll make that at the end just so you'll see the two different ones. Times pi times 10. Okay, so what I have now, 120 over 360 is 1/3. Okay, multiply by 3.14, and you're going to get approximately 20.93. Okay? Next problem. we're going to find the distance from Q to R if PZ, also a radius, if PZ is 12. Okay, the distance from Q to R with a degree measure is 60. Okay. 60 over 360 times 2 times pi times 12. 60 over 360 is 1/6. 2 times 12, 24 pi. I simplified that to 4 pi. Okay? 4 pi is an answer. If you are asked to find it to tenths or hundredths, you know you have to multiply by pi. Gets us to approximately 12.56. That's what we're dealing with. Okay, now we're going to find P, Q, R. 90 plus 60 TR is not the radius. TR is the entire diameter. Make sure you read carefully for that. Remember, the circumference of a circle can be written as 2 pi or 2 pi r, or, remember, 2 times the radius is diameter. We could say diameter times pi. Take out the middleman, which is what we're going to do. We're just going to say 15 pi. Okay? Okay. Simplify. Okay. Both of these have 30. Okay. We're going to break it down. Okay. And then I'm going to multiply by pi. Yeah, it's going to be okay. Yes, you'll also have the stills on these, so don't worry. Okay, and the last one, we're looking for Q, P, S. Q to P is 90, plus 30, plus 20 gives me 140. Okay. ZQ, yes, that is a radius. Okay. So I'm going to break this down. Okay, however you want to do it. If you want to put 20 into that, that's going to be 7 over 18 times 14 pi. Okay, and we're going to end up with 98 over 18. That's not it, that's 18. And that's going to be approximately, okay, and that's what you're dealing with here. Okay, each of these are relatively easy, calculator-wise, to figure out. Okay, that's what you're dealing with. Okay, assignment to follow.